let's talk about a new quantity that we're going to introduce right now, which is angular acceleration. And the symbol for angular acceleration is alpha. This is a symbol alpha. This is not A, this is a Greek alphabet alpha. Okay, so now we are going to discuss a situation in which the rotation speed is changing with time. So initially you can have a fan. Okay, so this is a fan. Initially at time is equal to 0. You can see that it is rotating with a certain rotational speed. Okay, but after a certain period of time, after some time, you can probably change the speed of the fan. So at a later time, you see that this fan is spinning at a higher speed, greater speed right now. Okay, so initially it was slow, now it is fast. So you can see the rotation speed has already changed throughout this period of time. So because the rotation speed change, you can see that initially it has an initial angular velocity, and we are going to use the symbol omega naught to represent the initial angular velocity. You can think of it as initial rotational speed. It's the same idea. Okay. After this period of time t, you reach a time which is t1, and at t1 your angular velocity reach a final angular velocity. So you represent with omega only without the naught. Omega here represents final angular velocity. Because you know that there's an increase from omega naught to omega, you know that there's a change in angular velocity omega. It changed from omega naught to omega. So there's a change. Because there's a change of angular velocity, you know that there's angular acceleration. Just like last time in chapter 2, you learned that there's a change in velocity, therefore you have acceleration. But here you have a change of angular velocity, that's why you have angular acceleration. Angular acceleration, again, the symbol is alpha. So let's try to determine the average angular acceleration. So last time in chapter 2, acceleration is change of velocity divided by time, right? So now average angular acceleration is change of angular velocity divided by the time taken. So you know that the change of angular velocity happens from initial to final. So for change, we take final minus initial. So it will be omega minus omega naught. Final angular velocity minus initial angular velocity. Once you get the change ready, for the time, you take the final moment minus initial moment. Then you get the duration, which is equivalent to t. Okay, so this is how you determine the average angular acceleration. You take the change of angular velocity divided by the time taken for that angular velocity to change. Very similar to the acceleration that you learned in chapter 2.